Is Earth really the best planet for life? According to an article in the Astrophysical Journal, data from NASA's Kepler Space Telescope suggests otherwise. These scientists have scrutinized over 2,000 exoplanets in their star's habitable zones, and their findings might surprise you. Among these exoplanets are over 120 gas giants, each potentially hosting at least one moon. Interestingly, these moons offer the greatest potential for discovering extraterrestrial life. Why? Because they might have liquid water, protection from cosmic radiation, magnetic fields, and even atmospheres, all of which Earth acquired with great difficulty and a bit of luck. But there's a catch. Despite astronomers' efforts and the observations of the James Webb Telescope, we haven't yet spotted any aliens. However, our own solar system holds a staggering 131 moons orbiting gas giants, and many scientists believe some of them could be cradles of extraterrestrial life. In this video, we'll explore which moons might sustain more than just bacteria, what Earth farmers could cultivate there, and why a cold and gloomy world orbiting Saturn could be more suitable for colonization than even Mars. Let's delve into what life could be like on the moons of gas giants in our solar system. Scientists used to think all the solar system's moons were dull, lifeless rocks, but some have defied those expectations. In the early 70s, NASA's Pioneer 10 and Pioneer 11 spacecraft provided our first up-close look at Jupiter's moon, Io. What they found was astonishing. Io's mass was larger than expected, and instead of the expected water ice and silicates, Io was filled with silicate rocks and iron, making it the densest moon in the solar system. Io's thin atmosphere piqued scientists' curiosity even more, but it was difficult to investigate due to radiation belts. In 1979, the Voyager probes finally overcame this hurdle. They captured high-quality images of Io's surface, revealing an absence of impact craters. Instead, they found evidence of volcanic activity. Jupiter's gravity and gravitational forces from its closest satellite heated Io's interior, causing silicate magma mixed with sulfur to erupt on the surface. This sulfur covers the moon's surface, creating a toxic layer deadly to any life forms. However, beneath Io's surface there are relatively safer places. Magma breaking through and cooling Creates lava tubes where water can be preserved, potentially allowing microorganisms to survive. On Earth, sulfate-reducing bacteria process sulfur compounds, which could be a hint at life's potential on Io. If we plan to colonize Io, we'll need to construct underground bases far from the volcanoes to avoid destruction by volcanic eruptions and protect against radiation. But is there a place similar to Io in the solar system but without such terrifying radiation levels? Another moon with active volcanism is Triton, Neptune's largest moon. The Voyager 2 probe provided our first data on Triton in 1989, revealing a complex topography and mysterious dark geysers erupting at extremely cold temperatures. Cryovolcanism, or volcano-like eruptions of water and other volatiles, occurs on Triton's surface. Only bacterial spores in a dormant state could potentially survive in such extreme conditions. Triton's underground water reservoirs, where these geysers originate, are not well understood. To colonize Triton, we'd need reliable insulation against extreme cold rather than radiation protection. Blocks of local ice could be used to construct habitats, and local resources like ammonia, methane, and nitrogen could be used for fuel and life support. The main obstacle to colonization, however, is Triton's distance from Earth, making transportation a challenge. Let's move on to Jupiter's other intriguing moons. The Galileo spacecraft, which arrived at Jupiter in 1995, sent back over 30 gigabytes of data. One of the most intriguing moons is Europa, where scientists observed changing lines on its icy surface. These lines indicate cracks in the ice above a liquid water ocean, which is believed to have twice the volume of Earth's oceans combined. This ocean's composition is still unknown, but observations suggest it could be similar to Earth's oceans. To obtain samples from Europa, we'd need to send a spacecraft to drill through the icy surface to reach a depth of 150 kilometers. However, recent observations suggest an alternative. Telescopes have spotted water molecules forming a trail when Europa's ocean spills into space through surface cracks. Collecting these samples could help us learn about the ocean's composition and whether life exists beneath the ice. Astrobiologists speculate that life on Europa could be similar to single-celled organisms on Earth, capable of surviving extreme conditions. Bacteria that thrive in oxygen-rich and oxygen-depleted environments, such as sulfate-reducing bacteria, might exist there. However, colonizing Europa would require advanced technology, including underground bases and radiation protection. Now let's turn our attention to Ganymede, Jupiter's largest moon. It's the only moon in the solar system where radiation poses almost no threat on its surface, thanks to its powerful magnetosphere, which even surpasses Mercury's in size. Ganymede's underground ocean is believed to have multiple layers, each potentially supporting different life forms. In salty water, larger organisms like radiolarians and artemia could thrive, offering a potential food source for colonists. Ganymede's atmosphere, though thin, contains oxygen, which could be extracted for breathing and other purposes. This makes Ganymede promising for colonization, as it offers radiation safety and resources for sustainability. The main challenge would be creating habitats that can withstand the extreme cold. But what if we look beyond Jupiter's moons? One moon orbiting Saturn stands out as a unique celestial body that might be the best place for life in the solar system: Titan. Unlike Mars, which has limited building materials, Titan has an abundant supply of hydrocarbons, both liquid and solid, which can be synthesized into versatile materials for building habitats, laboratories, and greenhouses. Titan's atmosphere contains nitrogen, methane, and ammonia, which can serve as fertilizers for cultivating plants. Water is also available, albeit in the subsurface ocean, but it can be extracted and purified for various uses. Titan's rivers and seas of ethane and methane offer hydroelectric power generation possibilities. The absence of oxygen in Titan's atmosphere eliminates the risk of combustion accidents, which is a concern on Mars. Colonists on Titan could use respiratory equipment, and with time, oxygen could be generated using cyanobacteria in the subsurface ocean. Furthermore, Titan's low gravity makes flying and even swimming possible. Colonists could use specially designed wings to fly in Titan's dense atmosphere or explore its ethereal lakes. While Titan poses challenges due to its distance from Earth, its unique characteristics make it an attractive candidate for colonization. In conclusion, the moons of gas giants in our solar system offer intriguing possibilities for colonization and the search for extraterrestrial life. While challenges exist, such as radiation, extreme cold, and distance from Earth, these moons provide abundant resources and potential habitats that could make them more suitable for human colonization than Mars or other celestial bodies. As we continue exploring our solar system, we may one day witness the expansion of human presence beyond Earth, finding new homes and opportunities among the stars. The choice of where to stake our claim in the cosmos remains an exciting prospect for the future of humanity. So, which moon would you choose for your new home in the solar system?